He is the man largely responsible for your fun, smart replies on your Gmail. He is the principal inventor of the optical scanner, the principal inventor of the first print-to-text reading machine for the blind, the first music synthesizer to recreate musical instruments. Yeah, you look pained.
Sounds good.
It does sound good, but above all else,
You can introduce me in the future.
no problem. And above all else, you are known for being one of the world's foremost futurists. You have a startling good track record of predictions. I think you're, what, 86%? Is that where you put yourself?
An analysis of 147 predictions I made in The Age of Spiritual Machines, which came out in '99, about 2009, were 86% correct.
All right, not bad, not bad. And what's getting the most attention lately is that you have predicted that in 2029, we're going to the machines will pass the Turing test, and in 2045, we will achieve the singularity, at which point human intelligence melds with machine intelligence.
Yeah, I've been consistent on 2029 for computers passing the Turing test, which I think is a valid test. There's no sort of simple language tricks you can deploy to pass a valid Turing test, with emphasis on the word valid. When I made that prediction in The Age of Spiritual Machines in '99, Stanford had a conference on AI experts to assess this startling prediction, and we took a poll. The consensus was hundreds of years. 25% thought it would never happen. My view and the consensus of AI experts has been getting closer together, but I haven't been changing my view.
All right.
2006, at a conference, AI 50, on the 50th anniversary of the 1956 conference at Dartmouth that gave artificial intelligence its name, the consensus was 50 years. Recent polls, the medians are 20 to 30 years. I'm still a little bit more optimistic, but there's maybe 25% who think I'm too conservative. And the pace of progress, just in recent months, has been quite startling. We can talk about that.
So let's talk about the pace of progress and the acceleration of ideas, which is what we are here to discuss. I want to talk about, first and foremost, the allocation of resources. This is all moving exponentially fast, and I would like to know what you think about managing access and talent and finances such that this progress can be maximized for social good.
Yeah, well, I mean, as I go around the world, people genuinely feel things are getting worse, and I think that's because our information about what's wrong with the world, including violence and poverty and environmental degradation, is getting exponentially better. I have all kinds of graphs. Poverty has fallen over 90% in the last 20 years in Asia, and comparably in other parts of the world. Solar energy is doubling every 2 years. It's only 5 or 6 doublings from meeting 100% of our energy needs, at which point it'll be using 1 part in 10,000 of the sunlight that falls on the earth. Literacy went from 10% to 90% in the world over the last century. Every aspect of human well-being is getting dramatically better, and we're going to see dramatic advances in longevity very soon, now that biotechnology, which is really reprogramming the software of life, is getting traction. We have a trickle of instances today that'll become a flood over the next decade. This is the most peaceful time in human history. People think I'm nuts when I say that. Didn't you pay attention to the incident yesterday and the week before? But that's because, a century ago, the village nearby could have been wiped out and you wouldn't hear about it for months. We have more information about what's wrong with the world, and we have an evolutionary preference for bad news because it was actually good for survival. The little rustling in the leaves, it might be a predator. It was very important that you pay attention to that. The fact that your crops were 1% better than last year was not so important for survival. So we tend to pay attention to bad news. We find it more interesting anyway. That's what's served up to us. People's algorithm for whether the world's getting better or worse is how often do they hear good news versus bad news, and that's really not a very good algorithm.
So, bad news. Let's talk about that, self-fulfilling prophecy here. Elon Musk was at the festival a couple days ago, and he was doing a Q&A, and he said, and I quote, "Mark my words, AI is more dangerous than nukes."
Well, I've been accused of being an optimist, and I am optimistic that we'll make it through these new existential risks. You have to be an optimist to be an entrepreneur. But I've actually spoken more about the risks of these new information technologies, artificial intelligence, biotechnology, nanotechnology, than most others. I started writing about it actually in the age of intelligent machines in the 80s. The age of spiritual machines talked a lot about the downsides of what was called GNR, genetics, nanotechnology, robotics, and started kind of a firestorm of this issue that these new technologies, which seem to be bringing a lot of good things, did have risks attendant to them. Subtle risks like privacy and bias inherent in AI, and then existential risks, which we've certainly seen portrayed in dystopian futurist movies. I do take comfort from the fact that we don't see the scenario that's portrayed in many of these movies, where it's the AI versus a brave band of humans for control of the world. There isn't one or two AIs in the world. There's several billion of them at last count, and they're very closely integrated with us. When I was in college, I had to take my bicycle across campus to get to the one computer we all shared. I went to MIT because it actually had a computer, and also to study with my mentor, Marvin Minsky. Now they're in our pockets, they hang from our belts, they're going to go inside our bodies. That's already started. And so AI is really a brain extender. That's why we use technology in general, is to go beyond our limitations. We couldn't reach fruit at that higher branch 1,000 years ago, so we created tools that extended our reach. Who here could build this building? So we have tools that leverage our muscles. A teenager in Africa can now access all of human knowledge with a few keystrokes with their smartphone. So they are brain and body extenders. They're going to literally make us smarter. We can talk about my scenario for how I think that will happen. And I think that tends to keep it safe. And we have a scenario or a paradigm for keeping these technologies safe. 40 years ago, some visionaries saw both the promise and the peril of biotechnology. Neither was actually feasible at that point, but they held a conference at the Asilomar Conference Center in California, which became known as the Asilomar Biotech Conference, and came up with the Asilomar guidelines for strategies to keep biotech safe and ethical standards for responsible practitioners. And there's been successive conferences. This has been updated every few years, and it's worked very well. We're now getting profound benefit. It's just a trickle today. It'll be a flood over the next decade from biotechnology. The number of people who've been harmed by either intentional or accidental abuse of biotechnology so far is approximately zero. That doesn't mean we can cross it off our concern list. Okay, we took care of that one. But it is a good paradigm for how to keep these ultimate technologies safe. We just had our first Asilomar conference last year on AI ethics. I think it is the most profound issue facing humanity. How can we reap the profound promise of these exponential technologies while managing the peril?
So you certainly believe that there should be some sort of ethical guidelines here and a degree of oversight. Is that happening in practice today? And
well, first of all, I mean, we have tremendous amount of regulation. So anytime AI or biotech or any of these technologies actually affect something, there's a tremendous amount of oversight. So let's say in medicine and biology, we've got the FDA and all kinds of regulations. Anytime any of these technologies affects anything we do, there's a tremendous amount of regulation. So it's not like we live in an unregulated society. And these things, influence us in terms of products and services. We have a myriad of regulations, and there's debate as to how extensive those should be. So it's not unregulated. It's very hard to regulate just a basic technology until it actually affects something.
Right. So, yeah, I mean, we're regulating after the fact, and I think that is what probably causes a lot of the hand-wringing, is this response that might come too late. Self-improving tech, how do you see us preventing it from running away from itself? If we're not regulating companies till after the fact, what are we doing right now in programming and engineering to ensure that self-improving technology and machine learning, the interest thereof doesn't diverge from human interests?
Well, I mean, there are issues now. For example, AI is learning from humans, and apparently some humans have bias and opinions that we don't want our AIs to share. So there's a lot of effort to try to recognize the bias in AI and try to address that. We try to counteract that. So anytime AI actually impacts the world, there's a lot of observation of it. You mentioned Smart Reply, which comes from my group at Google. We've gone to efforts to try to actually understand the emails correctly and not provide biased responses, but the software does learn from humans, so we have to constantly look after it, make sure that it reflects the kind of values we want. But at the same time, it's not a clear-cut issue, because we don't want to be censoring the software either and providing one set of values over another. We try to keep it neutral, but so that's one example of trying to monitor the behavior of AI. In terms of it being dangerous, I mean, again, if it's, for example, something that goes inside the body, there's a tremendous amount of regulation. There is concern of AI being used in military systems. I think really that strategy, I think that what makes the most sense is to try to practice the values that we espouse and hold dear in our social and political systems to begin with. And that may not sound like a foolproof strategy, and it's not. But AI is really an amplification already of human judgments, human policies, human ideas. And even before we had AI, human behavior has not been perfect. But I would say that we're moving towards a more peaceful world, a more democratic world, with the increase of communications. We had the first stirrings of democracy with Gutenberg's books. And the number of democracies in the world a century ago, you could count on the fingers of one hand. The number of democracies 2 centuries ago, you could count on the fingers of one finger. The world's not a perfect democracy today, but there are dozens of well-functioning democracies. It has become a consensus that that is how we want to govern the world. And this is the most peaceful time because we've become very sensitive to we have a natural empathy for small groups of people. So there's some outrage 10,000 miles away, and our hearts go out to that, and it's painful, but it actually generates action and reaction. There were 50 million people killed in World War II, and people might read about it in a small newspaper article days later. A century ago, you wouldn't even hear about these battles at all. By every measure, your chance of being killed in either state-sponsored violence or interpersonal violence is dozens, if not hundreds of times less than it was centuries ago, I think because of the prevalence of communication technology.
So I want to come back to something you said a minute or two ago about human bias and the bias that inevitably infuses AI as it learns from its creators, and a situation that is improving, but still as it stands right now, largely there's a lack of diversity amongst the engineers and programs who are creating this technology. Do you feel that there are concrete steps being taken on behalf of the engineers and programmers to make sure that that their own subconscious biases and their own empathetic tendencies aren't being infused or learned by the AI?
It's a good question, and I think a more significant issue is AI is learning from humans.
Right.
It'll read millions of documents, and that's how it learns about the world. There are significant efforts at all of these companies, Google, Microsoft, Apple, to debias software, recognize biases that we don't want. So, for example, software just reading about the world may come to the conclusion that surgeons are male, because that's what it reads. And that's not an association we want, because surgeons are females and can be. And so we try to correct that, but it's not it's a complicated issue, because then you're starting to provide your own values, and what should those be, and the whole idea of services provided by companies like Apple and Google is not to provide the values and ideas of the company. Nonetheless, there are efforts to try to debias software. A more significant issue than unconscious bias by the engineers is really the bias that exists in the human documents that these programs are learning from. So that's an ongoing issue. It's a major effort on the part of all these companies. We've looked at smart reply. It's actually complicated because we can't actually read people's emails, because that's another issue, which is privacy. So we have to actually wait for people to potentially complain. And we're actually getting very positive responses. We're not getting complaints that the software is showing bias, and that's because of efforts we put in to try to avoid that. But it's not a straightforward issue, because and it's the same thing with humans. I mean, human children learn from other humans and will adopt, consciously or otherwise, the biases in their midst. So it's a role of education, is to provide the values that we espouse as a society.
What you're saying about AI learning biases from documents is really interesting to me. Do you think there's some sort of conscious effort, or will there be some sort of effort on behalf of the engineers to, I don't know, create an algorithm or something such that the biases, let me rephrase that. Would there be a bias filtering process?
Well, that's exactly what is being worked on, to try to avoid really egregious examples of bias that we generally recognize as being out of the mainstream. But then you're trying to provide ideas and balances of views that are beyond what's reflected in human documents that the systems are learning from. And so then you have to decide what are the ideas that you want to espouse, what are ideas that you don't want the systems to learn, and that's complicated and difficult. The idea is really not to filter out. I mean, Google is really trying to provide information. When you search for something, you may find documents in your search that reflect ideas you don't agree with, but that's intentional. We don't want to be filtering out human ideas. We want really to be a neutral So it's an area of ongoing effort to try to avoid obvious problems, but where you draw the line is complicated.
You started this session by saying you were an optimist. And do you feel that you kind of get a bad rap for being an optimist?
Well, the world does have a pessimistic view. There was a poll taken of 24,000 people in 26 countries, and they were asked a number of questions. Poverty is a typical one, and people were very pessimistic. They were asked, has poverty gotten better or worse in the world over the last 20 years? 90% said incorrectly that it's gotten worse. Only 1% identified correctly that it's fallen by 50% over the last 20 years. So people really feel that on all these measures, literacy, poverty, health, things are getting worse when they're actually getting dramatically better every year, and exponentially so. But we don't recognize that. I had an onstage dialogue with Christine Lagarde at her annual meeting of the International Monetary Fund, and she said, well, where's the productivity enhancement that we're supposed to see from digital technology? I said, well, we don't measure it because we factor it out. We put it in the numerator and the denominator. So when this teenager in Africa spends $75 for her smartphone, it counts as $75 of economic activity, despite the fact that it's literally $1 trillion of computation and communication circa 1965, $1 billion circa 1980. It has millions of dollars of free information apps, just one of which, one of thousands, is an encyclopedia, much better than the one I spent thousands of dollars for as a teenager and saved up from my paper route. And it counts for nothing because it's free. So we don't count all of these fantastic productivity gains because a dollar of information technology is still a dollar. She said, okay, that's true of this fantastic world of digital technology, it's remarkable, but you can't wear information technology, you can't eat it, you can't live in it. And my next point was all of that's going to change as well. We're going to print out clothing at pennies per pound. Not yet. We need really submicron resolutions and faster speed and lower costs and 3D printing, but in the 2020s, there'll be lots of cool designs you can download for free, print out for pennies per pound. For clothing, people still spend money for cool proprietary designs, so the fashion industry won't go away, just as the music industry hasn't gone away with online music. You'll print out modules to snap together Lego-style houses and buildings. That's been demonstrated in Asia. We'll have vertical agriculture, hydroponic plants for fruits and vegetables, in vitro cloning of muscle tissue for meat, controlled by AI, very inexpensive. The 50% deflation rate that's inherent in information technology will then be attendant to these kinds of resources we don't associate with being information technology. And finally she said, okay, but the one resource that's you can't really produce in this exponential way is land. We're already very crowded together. And I said, it's really not true. We're only crowded together because we decided to crowd ourselves together. Cities was an early technology so we could aggregate, congregate, and work and play together. Try taking a train trip anywhere in the world and you'll see that 95% of the land is unused. And we can spread out when we have virtual communication that allows us really to work and play anywhere and still be together.
Okay, I'm going to pivot for a second because you've got some new work that illustrates principles and possibilities for a brighter future and a roadmap for your optimism, if you could talk about that for a second.
Yeah, well, about 10 years ago I had these fantasies of a young girl who was very precocious and very intelligent. It was really an exercise in the power of intelligence, and that's been my theme, but I've talked about it in an abstract sort of nonfiction way. So I was imagining what if there was a very precocious young person, say a young girl, who was remarkably intelligent. What impact would that have on the world? And so I wrote a novel called Danielle Chronicles of Superheroine. This is a picture of her. I don't know if you can see that from here. And the story is told by her sister Claire. Claire is a survivor of the Haitian earthquake. She's adopted by an American family when she's 6. 2 years later, her sister Danielle is born, and she tells the story of Danielle from 0 to 22. And Danielle solves a lot of problems. She cures cancer when she's 12. She finds that she actually can't distribute this cure because of the Food and Drug Administration, so she does a very clever end run around that, again, using her intelligence. She brings peace to the Middle East. She becomes president of the United States at 19. They pass a special one-person amendment for her. And in the preface, I state, this is really a thought experiment. What if one person was extraordinarily intelligent and also courageous and creative and compassionate? What impact would that have? And then I say, imagine if we were all Danielles, and that will happen by 2045. So this is a fictional way of really expressing my sentiments about the power of intelligence and personal courage. If you pick up this card, if you didn't get one on the way in, you can pick it up on the way out and get a free book inscribed by the author, which is me, when the book comes out this summer. Your shipping information won't be shared with anyone, but that's a free copy of the book.
Says the guy from Google. We tease because we love.
It also includes 2 nonfiction companion books, which is kind of a literary first. One is How You Can Be a Danielle, which is practical advice, how you personally can use your intelligence and courage to positively impact the world, including children. And then there's another companion book called A Chronicle of Ideas, which is Danielle's and my unique spin on the concepts in the book.
And we have a trailer for that, if we could cue that up real quick.
That'd be great.
People always ask me, what's it like? What's it like to be the sister of a superheroine? I tell them it's fun. I remember when our stage was small and we'd sing our stuffed animals to sleep. I tell them it's beautiful. I remember the night we traveled across Zambia by donkey. We'd come to help with the water crisis. I tell them it's exhilarating. I remember the moment Danielle resolved the Libyan civil war. I tell them it's inspiring. I remember Danielle at the congressional podium, uniting left and right, her greatest stage yet. And I tell them sometimes it's hard. Danielle's brilliance can't always save her from sadness. It's a good thing I'm here.
Claire, I need you.
What's it like to be Danielle's sister? It's the best material a writer could ask for.
We've spoken, and you've spoken before, about the hierarchy of intelligence. Danielle clearly has augmented intelligence. How far up the hierarchy?
Okay, so this is a 200 million year story. How much time do we have?
We're fine.
So 200 million years ago, mammals evolved with a brain structure called the neocortex, which means new rind, which is an outer layer of the brain that could actually understand the hierarchical nature of the world and could invent new behaviors. So these early mammals were rodents, and they could invent a new behavior. So they're escaping a predator, its path is blocked, it'll invent a new behavior to cope with that. Probably wouldn't work, but if it did work, it would remember that. That could actually spread virally through the community. Another mouse watching this might go, that was really clever going around that rock. I'm going to remember to do that. And they would invent a new behavior. Animals without a neocortex, which is to say non-mammalian animals, couldn't do that. Didn't help very much because all the non-mammalian animals were very well evolved for their ecological niches. So the mammals stayed out of the way, and not much happened for 135 million years. 65 million years ago, something did happen. There was a sudden violent change to the world. If you dig down to an area of rock reflecting 65 million years ago, the geologists will explain that this shows a sudden violent catastrophic change to the environment. And we see it all around the globe. And we call it today the Cretaceous extinction event because that's when the dinosaurs went extinct. 75% of all the animal and plant species went extinct because it couldn't cope with this change. That's when mammals overtook their ecological niche. And to anthropomorphize, biological evolution said to itself, this neocortex is pretty good stuff, and it began to grow it. And now mammals got bigger, their brains got bigger at an even faster pace, taking up a larger fraction of their body, and the neocortex got bigger even faster than that, developing these curvatures that we associate with a primate brain. And so now primates really became ascendant. 2 million years ago, biological evolution decided to expand the neocortex even further and develop these large foreheads to house the frontal cortex. Up until recently, it was thought that frontal cortex must be qualitatively different because it does such different things. My thesis has always been it was just an additional quantity of neocortex. Now, the neocortex is organized as modules. Each module can recognize a pattern, and they're organized in hierarchies, and we create that hierarchy with our own thinking. It's a thesis I actually had 50 years ago. It's how I got to meet President Johnson, and I've been thinking about this for 50 years. We're using an architecture along these lines for Smart Reply and other software at Google that can actually understand the meaning of natural language. So we got an additional amount of neocortex 2 million years ago with these large foreheads. Remember what we did with it? Well, we were already doing a very good job of being primates, so we put it at the top of the neocortical hierarchy. And as you go up the hierarchy, things get more interesting. At the very bottom of the hierarchy, I can tell that that's a straight line. At the top of the hierarchy, I can tell that that's funny or that's ironic. So that additional neocortex, that additional levels of hierarchy was the enabling factor for us to invent language and art and music. Every human culture we've ever discovered has music. No primate culture has music. There's debate about that, but I believe it's the case. So we're going to do it again. We're going to create synthetic neocortex in the cloud. We have rough models of the neocortex already. It's not perfect, but that's what we're trying to do today. I think by the 2030s, we'll have very realistic models of the neocortex, and we'll have medical nanorobots that go inside our bodies, keep us healthy by extending the immune system, providing virtual and augmented reality from within the nervous system, but most significantly, attaching the top levels of our neocortical hierarchy to synthetic neocortex in the cloud. Just the way that this connects to the cloud, and these are brain extenders. They're not directly connected in the brain, and they're not really connecting to extend our neocortex today, but that's what it'll do in the 2030s directly from our neocortex. The only difference from what we did 2 million years ago is that was a one-shot deal. If our foreheads kept expanding, birth would have become impossible. This expansion wirelessly into the cloud will not be a one-shot deal because the cloud is not limited by a fixed enclosure. It's growing exponentially as we speak. So it will become a hybrid of biological and non-biological intelligence. The non-biological part will grow exponentially. And again, just like it did 2 million years ago, we'll put it at the top of the neocortical hierarchy. So we'll invent new ways of relating, communicating with each other, new art forms that we can't even imagine today. Try explaining music to a primate, or language to a primate that just doesn't have enough neocortical capacity to comprehend those concepts. We'll again create fantastic new ways to relate to each other. But that, as I said earlier, is what we do with technology. It extends our reach and we go beyond our limitations. We're the only species that does that.
So
Did that answer your question?
it does, but it also essentially, you're essentially projecting that after a certain point, or at a certain point, we'll be able to augment creativity. And
Right.
what does that mean for unenhanced creativity? And how do we measure one against the other?
Well, I mean, who's unenhanced? Choose not to use cell phones. I'm not sure. They do use some technology. 98% of people use some form of digital enhancement. No, who here could do their work or get an education without the brain enhancers we already have? And people say, oh, well, only the wealthy be able to afford these forms of enhancement. I say, yeah, like smartphones, of which there's 2.5 billion in the world today. There'll be 5 or 6 billion in a few years. In fact, you had to be wealthy to have a mobile phone 20 years ago, and they didn't work very well, and they only did one thing, which is make phone calls poorly. Today they do 1 million things, and they're in billions of hands. So that's because of this 50% deflation rate with digital technology. It's only affordable by the wealthy at a point in time where they don't actually work. By the time they work well, they're ubiquitous.
I guess let's not say enhanced then for a second. Let's talk about augmented creativity, creativity post-singularity.
Well, I mean, we're already augmented. My father was a brilliant musician. He couldn't hear his orchestral compositions. He'd have arguments with funders late at night to fund assembling an orchestra so he could hear his compositions. Then finally, when he got the money, I'd be up late with him running off scores on a mimeograph machine, which was hand-fed, and then he could finally hear his composition. But he couldn't change it, except maybe a few notes on the fly. I'd have to dismiss the musicians and start over again. Today, a kid in her dorm room can create a whole orchestra or a jazz band, with her MIDI keyboard and synthesizer software. So and software is creating walking bass lines and help calculate rhythmic progressions, and there are all kinds of writing tools. More sophisticated ones are coming. So it's already enhancing our creativity. We'll literally be able to comprehend more complex forms of communication, just as, say, music is a more sophisticated form of communication than what primates can do, when we actually can enhance our neocortex with its extension in the cloud.
Creativity, art, empathy, these are often the qualities to which humans assign meaningful interaction.
Right, and they exist at the top of the neocortical hierarchy.
What does meaningful interaction mean to an AI, to machine intelligence?
Well, AIs are not at human levels yet. They can do lots of things that we used to ascribe to human intelligence. In fact, one definition of AI is the field of computer science problems we haven't solved yet. As soon as we solve a problem, we say, oh, well, it's obvious that computers can play superhuman levels of chess, because that's just a combinatorial game, of Go. The rules are pretty simple. It was only a year ago that people said, oh, well, computers will never play master games of Go. It's also interesting to note that once a computer does something at sort of average adult human levels, it very quickly soars past it. So it's a moving frontier. Just a few weeks ago, computers for the first time can take these reading comprehension tests where you read a paragraph and then you have to answer questions about it at slightly better than average adult performance. There's been some criticisms of the test, that the test doesn't really assess what's called multi-chain reasoning, where you have to take several different things in the paragraph plus some real-world knowledge and put that all together to answer the question. So we're creating more sophisticated tests. But clearly, computers are, the range of performance is getting broader and broader. Driving a car used to be considered a very complex thing, and it's not a simple task like just playing a board game. You've got to take all kinds of things into consideration, including trade-offs of what the risks are of different types of actions. And the Waymo cars have gone 3.5 million miles with no incidents, which is better than humans would do. So the range of activities is getting broader and broader. Still, actually dealing with human language at human levels, say reading a novel and describing what it's about and writing a review of it and so on, these are still beyond what computers can do. That's the significance of my 2029 milestone. And I think once they achieve human levels, they will quickly go beyond it. Like we saw in Go, it was only, I don't know, a year and a half ago that computers were sort of fair, average Go players. Then they quickly defeated Lee Sedol, one of the best, if not the best, Go player in the world. And then AlphaZero quickly soared past that, using no human training. So we see very rapid progress once a computer can do something at human levels. But again, it's not an alien invasion of intelligent machines from Mars. We create these tools to make ourselves smarter and extend our own reach, and that will be the ultimate application of AI.
At some point when these tools do reach our level of intelligence, do you foresee there being a point at which we should be assigning some sort of rights to these machines?
Well, it's an interesting question. I wrote kind of a tongue-in-cheek movie called The Singularity is Near. It's the movie accompaniment to my book, The Singularity is Near. It goes back and forth between a documentary and a narrative story of a young AI named Ramona, and gets more and more intelligent, more and more human-like. She finally decides to hire Alan Dershowitz, who's a famous civil liberties lawyer, who plays himself, to press for her legal rights to be recognized as a human. And the judge says, okay, I'll grant you human rights if you can pass a Turing test. So she gets coaching from Tony Robbins, who plays himself, to learn the secret of what it means to be human.
I said, this is fiction?
That was fiction, yeah. And it's somewhat tongue-in-cheek, but it is a serious issue. There are features of artificial intelligence that AIs can share their skills in ways that humans can't do. We can teach each other, but we can't just transfer our thoughts and skills directly, like a digital file. So we don't think of AIs having human qualities, but once they really do have the depth of human intelligence, and the essence of a Turing test is to actually be convincingly emotional and empathetic. That's really the cutting edge of human intelligence. And once it does that, in my view, these are conscious beings. But I will say that consciousness is not a scientific issue. Some scientists talk about it like it's just an obvious thing that you can measure. There's no falsifiable experiment you can run that definitively says, okay, this one's conscious, this one isn't. There's no machine you can build, slide an entity in, the green light goes on, okay, this one's conscious, this one isn't. That doesn't have some philosophical assumptions built into it. So one philosopher might require that it be squirting human biological neurotransmitters, otherwise it's not conscious. Dan Dennett, an AI philosopher at Tufts, would want it to make sure that it had a model of its own thinking. It didn't matter what the substrate is. That's maybe a little closer to my view. But these are all philosophical leaps of faith. There's really no scientific proof. So some scientists, including my mentor at times, Marvin Minsky, would say, well, you're right, it's not scientific, so therefore it's an illusion, we shouldn't waste time on it. That's not my view either, because our whole moral system is based on consciousness. A young child is precious because he or she is conscious. conscious entities are only important insofar as they affect the conscious experience of conscious entities. So an important moral debate is who and what is conscious. That's behind the whole issue of animal rights. And we will debate the consciousness and therefore the moral rights and rights to liberties and so on of AIs. But it'll be tricky because of these other properties of AIs. But we will then ultimately enjoy those features as well.
Given the rate of progress, it's a philosophical issue, but it will be we'll be forced to confront it because of science.
Exactly.
Can you give us a date when we'll have to seriously consider?
Well, 2029.
2029, that's it?
And we'll merge with them in the early 2030s. A whole nother exponential trajectory is nanotechnology. There's a lot of progress being made, and there's already little devices actually you can put in your bloodstream that will carry out diagnostic and therapeutic procedures. I believe they'll be quite sophisticated in the early 2030s. As I mentioned, they'll extend our immune system. That's the third bridge to radical life extension. They will provide virtual and augmented reality, but most importantly, they will extend our intelligence and will merge with these intelligent entities. But it's really a continuation of what we've been doing for thousands of years with technology, is overcoming our own limitations, and no other species really does that.
Okay, I'm going to turn it to audience questions now because we've got some very good ones. What's the next major industry to die?
Well, I think every industry
As long as we're talking optimism.
every industry is transformed, so they don't die, they just get changed in nature. So if you viewed yourself in the horseshoe industry in around 1910, you probably didn't have a bright future, but if you saw yourself in the transportation industry, you did. So we're going to have transformations, let's say, of agriculture, which is already greatly transformed. 38% of the population in the United States and Europe worked in agriculture in 1900. It's 2% today, but it's going to be further transformed, as I mentioned earlier, with vertical agriculture. Transportation is going to be greatly affected, not only by new means of autonomous vehicles, both on land and that fly, but really highly realistic virtual and augmented reality where you could be together. I'm giving a presentation actually in a few weeks to Australia where it'll be very realistic. I'll be able to walk along on stage and interact with other people on stage, and it'll really look like I'm there. It's kind of clumsy in that it's a lot of equipment required, so it's not something I can kind of carry in my suitcase, but we will actually be able to do that quite easily, and as we get to the mid to late 2020s, we'll be able to physically aggregate and do everything we do when we're actually physically together, including hugging each other, even if we're far apart. So this need to aggregate in cities and be very crowded and ignore 95% of the usable land, we will overcome. Okay, so we've talked about cross-prohibitive arguments regarding tech, but let's say I have $1 to $3 million by 2050. Am I going to be able to pay for immortality? Well, I talk about three bridges to radical life extension in my health books and also science books. Health books co-authored with Terry Grossman, MD. Bridge 1 is what you can do right now. Bridge 2 is now unfolding, which is biotechnology, being able to reprogram the software of life. The enabling factor for that was the Genome Project. That was a perfect exponential. It doubled every year. The cost came down by half every year. That first genome cost $1 billion, finished in 2003. It's now down to $1,000. And our ability to understand, model, simulate, and most importantly, to reprogram this outdated software is also growing exponentially. And we're seeing now profound clinical applications. We can now fix a broken heart from a heart attack by reprogramming adult stem cells. I'm involved with a company where we're growing organs, run by Martine Rothblatt, who had spoken here at South by Southwest, kidneys, lungs, and hearts, installing them successfully in primates, which are pretty close to humans, coming to a human near you soon. This is all going to unfold in the next 4 or 5 years. 10 years from now, this will be a flood, and we'll really be able to program ourselves away from things like cancer. Immunotherapy is actually a very bright spot in cancer treatment. There's some spectacular trials where groups that are stage 4 terminal cancer have been brought to full remission. So all of this is unfolding and will be really mainstream over the next 10 years. The third bridge is medical nanorobots. With these, basically, we have already devices in our bloodstream that keep us healthy. They are blood cells, our T cells, and other cells of the immune system. But they evolved tens of thousands of years ago, and it was not in the interest of the human species for us to live very long. So they didn't work against things that get us later on in life, like cancer. It says, oh, that's me, and doesn't go after it. So we can basically create non-biological T cells that are programmed to go against all pathogens, also overcome diseases of the organs, metabolic diseases. For example, the pancreas doesn't produce insulin, that's diabetes. So these devices will monitor the bloodstream for ideal levels of all these different nutrients, carbon dioxide, oxygen, toxins, puts them in, takes them out, augment the function of the organs. There's a scenario actually for every disease and aging process. So this is a 2030s scenario. So again, this will be expensive when it doesn't work. By the time it's perfected, it'll become like vaccines. Everyone will have access to it, ultimately very inexpensive. There's inherently a 50% deflation rate in information technology. That's what's keeping inflation in check, not policies by the government. It's really this increasingly pervasive influence of information technology. So ultimately, these things will be quite inexpensive.
All right, next audience question. What near term, as in 1 to 3 years, innovation are you most excited about? And please be specific.
Well, yeah, 3 years actually brings us to the early 2020s. And I think then 3D printing will really get going, because we'll reach submicron resolutions, which is what you need for the interesting applications, like printing out clothing. So we'll increasingly be able to create the physical things we need. Vertical agriculture, I think it's more like 5 or 6 years for that to get going. Virtual realities had really a false start. I think that's actually typical. I've written about the life cycle of technologies. There's usually a lot of hype about a technology seen by visionaries, but the timing isn't there. Exponential growth doesn't mean instantaneous growth. So this audience probably doesn't remember the 1990s when if you had the website dog.com, you were a billionaire with the internet boom. And around the year 2000, the financial community said, now wait a second, you can't really make money with these internet companies. And we had the internet crash that almost brought down the world economy. But then it gradually came back as we actually got the price performance that we needed. So now you have little internet companies like Google, Apple, and Microsoft that are worth, I think, around $2 trillion together. The same thing will happen with things like virtual and augmented reality. It was a premature start last year. There's some really interesting devices, some of which are here, that look very promising. They need to be much more streamlined. You can't carry a big bulky device around. Ultimately, they'll be kind of in our eyeglasses and ultimately contact lenses, and we'll be used to being in augmented reality all the time. So you could be sitting around a table and a friend could be there, and it really will feel and seem like they're there, even though they're not. So virtual and augmented reality, I think, will take off in about 3 or 4 years.
All right, maybe a bit of an existential question for you, but in general, what are futurists going to do after the singularity?
There'll still be a future.
Like, you're going to take a day off?
We
Or?
can actually start futurism for real, because we have to worry about all this legacy technology we have in the physical world. But the term singularity really is a metaphor on the event horizon that we see in a physics singularity. So we borrowed this metaphor from physics, and it's really not the infinite point in the center. Actually, physics does not allow an infinite point of mass and energy. It just gets beyond our ability to measure. And there's an event horizon around that so-called singularity that's very hard to see beyond because the information is kept in by gravity. That's a physics singularity. So in this historical singularity that we envision, it's again very hard to see beyond that horizon, because by 2045, I estimate we'll be enhancing our intelligence a billion-fold. That's such a profound transformation that we borrow this event horizon metaphor. But even in the physics singularity, we can use our intelligence to describe what it would be like to fall into a black hole, and we could describe what we'd see and what we'd feel if we could actually survive it. Similarly, in the historical singularity, we can describe what things would be like. We can use metaphors such as we'll create forms of music that we can't imagine today that will be like what music is to humans compared to primates. And so we can talk about it in that way. But there'll still be a future. It'll just be changing much more rapidly, and it'll be much more profound, and I think we'll have a much greater need for futurists.
Okay, 2 more questions I want to get to here. First, the very important one, which is, what do you think of the theory that we may live in the Matrix?
Well, we have to define what a simulation means. So it's generally viewed that a simulation means that somebody created a computer program with a simulated world, like a computer game, and there are creatures that live inside that. And so we can imagine if a game like that became ultra sophisticated and somebody actually created a simulation of the whole universe that we seem to live in, that would be living in a simulation. So basically that some teenager for her science fair experiments has created the world that we live in. Then the concern is, how do you convince that teenager to keep the simulation going? And I think the answer is do interesting things. So be creative, create very entrancing music. The singularity is actually quite interesting. So if we can actually have a successful singularity, we'd keep the interest of that game maker in this other universe. But another view is it's not necessarily created by a conscious entity in another universe, but that the universe itself is a computer. There's certainly a lot of evidence for that. We live in a universe that encodes information. And it's actually quite a coincidence, because there are about 50 different constants in the standard model of physics, and they have to be within very precise levels for us to live in a universe that can actually encode information. But by the anthropic principle, we do live in such a universe. We wouldn't be talking about it if we didn't. So we live in a universe that is able to create subatomic particles that can relate to each other and encode information, and then create atomic structures that encoded information. And then there's been a series of indirections. Atoms aggregated into molecules. Molecules can encode information. There evolved a particular molecule, DNA, that could actually very systematically encode information and actually then create creatures that were described by that code. Those creatures then developed brains, and those brains then learned information. Those brains combined with an opposable appendage so that we could actually create technology, then created computers that could encode information. We then gave those computers intelligence based on trying to understand our own intelligence, and then enhanced our own intelligence by merging with those devices. All of that, all of those grand evolutionary steps resulted from the fact that we do live in a universe that encodes information. And a universe that encodes information is a computer. So you could say we do live in a simulation. But whether or not there's some grand creatures watching our simulation and doing that instead of watching weekly TV programs is a philosophical question at this point.
So I'm afraid we have to wrap it up, but I think the reveal that we are living in the Matrix is probably a good note to end on. So, Ray, thank you so much for taking time to
pleasure.
be with us today.
Thanks.